Okay, example 4. 2 dice are rolled. What's the probability that some of the numbers rolled is a 7, a number greater than 8? Now this is a lot of your board games. Monopoly is one, for example. You use 2 dice, right? And Monopoly is a game based on probability. And if you know probability well, you can kind of get a feel for the chances of somebody landing on one of your properties, and that's when I want to start building houses and hotels, because they're kind of in the striking zone. They're more likely to land on one of my properties, so let me go ahead and spend some money on that now. Because if they don't land on your property, you buy those houses and hotels, all of a sudden you're out of some money, maybe you're going to be in trouble, right? But if they're like 7 spaces away, there's more ways to make 7 than there is to make anything else on 2 dice when you roll. Okay? You have, the first die could be 1 through 6, the second die could be 1 through 6. And the way we get the total of the dice is we add the 2 dice up. So this is just basically an addition table happening here. 1 plus 1 is 2, 1 plus 2 is 3, and so on. So if the first die is a 1, there's 6 outcomes possible, 2 through 7. The first die is a 2, plus 1, 2, and so on, makes 3, 4, 5, 6, 7, 8. And just between those two, notice there's one way to make 2, 2 ways to make 3, 2 to make 4, 2 to make 5, 2 to make 6, 2 to make 7, 1 to make 8. All right? Moving on to that first 3, plus 1, 2, and so on, makes 4, 5, 6, 7, 8, 9. So now there's only 2 ways to make 3, then we're done with 3s. Now there's 3 ways to make 4, right? And then 4 and 1 and all these makes 5, 6, 7, 8, 9, 10. 5 and all those make 6, 7, 8, 9, 10, 11. And then 6 with all those makes 7, 8, 9, 10, 11, 12.
It's like a row. Right?
Yeah, it's backward diagonal rows if you're going this way, or upward diagonal rows if you're going that way. But looking at this, this is every outcome possibility for 2 dice. It seems like 2 through 12 is what you can get, right? So if you're thinking in that sense, there's 11 outcomes, right? 2 can happen, 3 can happen, 4, and there's 11 things can happen. But 2 only happens once, 3 happens twice, 4 3 times, 5 4 times. And every one of these here is different. Every one of these here is different. So even though they're all 6, there are different ways of getting 6. And they're all 7, but there's different ways of getting 7. So looking at the blue represents our sample space. Not only what numbers you can get, but how many times you can do them. So the sample space here contains exactly 36 outcomes. Anytime you're doing a 2 dice roll, there's 36 outcomes. If you roll 3 dice, there's 216 outcomes. All right? They go all the way from 3 through 18. All right? If you roll 4 dice, there are 1,296 outcomes. 5 dice, hard to multiply in my head. 7,000, what did I say the other one was? 216, 1,296, 7,200 plus about 7,700 and something outcomes. Each time you add a die, you're adding a lot of outcomes. All right? So, 36 outcomes for 2 dice. We only do 2 dice in this class. Don't worry about those other ones. But just know that as you add more dice, it's going to be a lot more outcome possibilities. Part A, the probability of rolling a 7. Okay, so probability always is how many ways are there to do what we want divided by how many ways are there to do anything. There's 36 ways to do anything. And if we're looking for 7, 1, 2, 3, 4, 5, 6 ways to make 7. So the probability of getting 7 is exactly 1/6. The same as rolling any number on any die, right? Right. So you have a single die, roll a 1, 1 out of 6. 2, 2 out of 6. 3, 1 out of 6. 2 is 1 out of 6 also. 4, 1 out of 6. Rolling a 7 is a 1 out of 6 probability. So if you roll a die 6 times, 2 dice 6 times, at least 1 out of every 6 times you should expect a 7 to happen. Doesn't mean it will, but it's likely. All right? The other question, part B, says probability of greater than 8. What does greater than 8 look like in our sample space?
10 out of 36.
But like what numbers?
9s, 10s, 11s, and 12.
All these numbers down in the corner fit the description of greater than 8. And as Amber already said, there's 4, 3, 2, 1, a total of 10 numbers. I don't know why I wrote 9 there. Greater than 8. Greater than 8 is 9, 10, 11, 12. There's 10 numbers that fit that description out of 36 total numbers. And 10 and 36 divides down to 5/18. Again, I'm looking for fractional answers here. I do not want decimal answers to these problems. All right, so 2 dice are rolled problems. They happen a lot. If you have this on your paper right now, you can always refer back to this sheet to see this sample space. That's fine. I'll believe you've looked at it. But that's a sample space you need to be able to recreate on a test. So make sure you can do that each time. All right. One other way to do a 2 dice sample space, if you prefer, let me show you one other way. Outcome, number of ways. Okay, so again, our goal for a sample space is to know how many things there are and how many of each thing there are within that sample space, right? So when you're rolling 2 dice, your choices are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What happens the most? Which one happens the most? 7 happens the most, right? How many times does 2 happen? 1 time. Go back here. 1, right? And how about 12? Once, right? So if you just know that, we go from 2 to 12, we start at 1, hit our maximum at 7, end at 1, and we're going up. There's 1 way to get 2, 2 ways to get 3, 3 to get 4, 4 to get 5, 5 to get 6, 6 to get 7, then it starts going back down 5, 4, 3, 2, 1.
But just because it has a higher change doesn't mean that it's going to be that way.
Yeah, exactly. And so just because 7 is the most doesn't mean 7 is going to happen. I mean, you could roll 15 12s in a row. I'd check the dice, but it could happen. All right. So probability is not about what's going to happen; it's just what's more likely to happen. So 7 is the most likely to happen, but honestly, there's only 6 ways to make 7. There's 30 ways to make everything else. So the chances of not getting a 7 is higher than the chances of getting a 7. But the chances of getting a 7 is higher than anything else. But again, this makes the same sample space. These add up to 36. If I need to know greater than 8, notice greater than 8, 4, 7, 9, 10 ways to do it. Probability of getting 7. 6 ways to do it out of 36. So you can get the sample space that way also. Take your pick. The chart I like because it's a little bit more descriptive. It gives me the actual picture of every possible outcome. But again, this gets me the information I need also, and it's a little bit quicker to write down. Let's say you're on a test and you want the quicker way to do it. That'd be the quicker way to do it.